Okay, this is test number 2, problem number 1. It says find the exact solutions for the following equations. Log of x cubed equals the square root of log of x. So the first thing we want to do is pull out that cube that's directly attached to the x. So we're going to write 3 log of x equals, and we're going to rewrite the square root of log of x as log of x to the 1/2. And now to get rid of the 1/2 exponent, we're going to square both sides. So we get 3 log of x all squared equals log of x. So let's simplify a little bit. This is 9 log of x squared. Make sure you distribute that square to the 3. That equals log of x. Now, since we're finding the solutions, we want to set this equation equal to 0, so we're going to pull over the log of x. So we're going to subtract. We have 9 of log of x squared minus log of x equals 0. Since both of these terms have a log of x, we're going to pull out 1 from each. So we're left with 9 log of x from the first term, and then minus 1 from the second. That all equals 0. Now, since we have multiplication on the left side and both of these terms multiply together equals 0, we can set each one equal to 0. So log of x equals 0, or 9 log of x minus 1 equals 0. So let's go ahead and solve for x. For the first one, this is 10 to the 0 equals 1. That's one of your properties. So x equals 1. And for the second one, we have log of x equals 1/9. And so x equals 10 to the 1/9. So now before we can circle both of these solutions, we need to check. So we'll come over to the right side to check. So we have 1, x equals 1, so we have 1 cubed, and that's 1, and that's greater than 0. And on the right side, it's square root of log of x, and log of 1 is greater than 0. So 1 is a solution, so we can go ahead and circle x equals 1. Now let's plug in 10 to the 1/9. 10 to the 1/9 cubed equals 10 to the 1/3, and that is greater than 0. So 10 to the 1/9 is greater than 0. So we can circle that solution as well. So our solutions are x equals 1 and x equals 10 to the 1/9. Okay, this is problem number B. We're finding the exact solutions to this equation. 4 to the x minus 3 times 4 to the negative x equals 8. So the first step is we're going to rewrite this as 4 to the x minus 3 divided by 4 to the x equals 8. And to get rid of that 4 to the x in the bottom, we're going to times everything by 4 to the x. So we have 4 to the 2x minus 3 equals 8 times 4 to the x. And we're finding solutions, so we want to get this equation equal to 0, so we're going to subtract the 8 times 4 to the x from the right. So we have 4 times 4 to the 2x minus 8 times 4 to the x minus 3 equals 0. And now we can see that we can use substitution and let t equal 4 to the x. So off to the side we'll write t equals 4 to the x. So let's rewrite this equation as t squared minus 8t minus 3 equals 0. And we're going to have to use the quadratic, so we have 8 plus or minus the square root of negative 8 squared minus 4ac all over 2 times our a. So let's simplify this equation. We have 8 plus or minus the square root of 64 plus 12, all divided by 2. And so that equals 4 plus or minus the square root of 19. Now remember, we substituted t equals 4 to the x, so we need to set this equal to 4 to the x to solve for x still. We have 4 to the x equals 4 plus or minus the square root of 19. And let's take the ln of both sides to get the x out of the exponent. So we have x times ln of 4 equals the ln of 4 plus the square root of 19. We're not going to use 4 minus the square root of 19 because that is less than 0, so it's not a solution. And divide both sides by ln of 4, we get x equals ln of 4 plus the square root of 19, all divided by ln of 4. And that is our solution. Okay, the next problem, number 2, says convert the following angles from degrees to radians or radians to degrees where appropriate. And then we need to simplify our answers completely. So the first one, we have degrees. And to go from degrees to radians, we need to multiply by pi over 180. So we have 48 times pi divided by 180. And simplifying, we will get 4 pi divided by 15. For the second problem, B, we have pi over 27, and so we need to convert this into degrees. So to convert into degrees, we have to multiply by 180 divided by pi. So we have pi divided by 27. That will need to multiply, like I said, by 180 divided by pi. Our pi's will cancel, and we're left with 180 divided by 27, and that'll reduce to 20/3 degrees. Okay, this is problem number 3. It says we need to break apart and simplify the following expressions. So we're going to use our rules that I've written out on the right. We're going to use the ln of u divided by v can be broken up as ln of u minus ln of v, or ln of u times v can be broken up as ln of u plus ln of v. So the first thing that we need to do is we need to split this fraction into 2 parts. So we can rewrite this as ln of the square root of y minus ln of x to the 4th times the cube root of z plus w. And then let's rewrite ln of square root of y as ln of y to the 1/2 minus ln of x to the 4th. And let's write this cube root as z plus w to the 1/3 as well. Okay, and let's use our rule that we can bring the power down in front of the ln. So we have 1/2 ln of y minus our ln of x to the 4th. And instead of multiplying these two, we're going to take the ln of x to the 4th plus ln of z plus w to the 1/3. And we still have 1/2 ln of y. And let's pull that 4 exponent down in front. So we'll have a negative 4 ln of x. And we have that 1/3 we'll pull down in front of the next ln. And now let's distribute our negative through. So we have 1/2 ln of y minus 4 ln of x minus 1/3 ln of z plus w. And that's the farthest we can simplify. So this is our answer. Okay, once again, we need to simplify for b. We have log base b of the fourth root of x times w all divided by y squared plus z. So the first thing we want to do is we want to get rid of that 1/4, that fourth root. So we're going to rewrite this as log base b of x times w all divided by y squared plus z, and we're going to write that fourth root as a fourth power. Now we can bring down that fourth in front of the log, so we have 1/4 log base b of, and inside this log we have a division, we have a fraction, so let's go ahead and break this up using our rule where we can subtract. So we have log base b of x times w minus log base b of y squared plus z. And we have multiplication in the first log, so we can again break this up even further. So we have 1/4 log base b of x plus log base b of w minus our last term, log base b of y squared plus z. And we cannot break that up because it's already in addition. It's not using multiplication or division. So this answer is our simplified answer. Okay, this problem number 4. Combine the following into a single simplified long term. So instead of what we were doing in problem 3, we're going to be going backwards. We're actually going to be combining these terms using those rules that we just had. We know that all these coefficients in front of the logs are powers, so we're going to rewrite this and put them in the power, in the exponent. So we have log base a of x to the 5th minus, let's rewrite this, x to the 5th, minus that 1/2 will be a square root. So minus log base a of the square root of 3x minus 4. And then minus our log base a of 5x plus 1, and that's cubed from the 3 in front of the log base a. And now I'm going to pull out a negative from the last two terms, so we're going to rewrite this as log base a of x to the 5th minus log base a of the square root 3x minus 4 plus log base a of 5x plus 1 cubed. And now we see we have addition with the last two logs, so we can go ahead and multiply those together. So we have log base a of x to the 5th minus log base a, the square root of 3x minus 4, and we're going to times it by our 5x plus 1 because we combined those two terms using our rule. And last we have this subtraction symbol, so we're going to combine those using division. So we have log base a of x to the 5th all divided by square root of 3x minus 4 times 5x plus 1 cubed. And this is our single simplified log term. Okay, B, we're going to be doing the same thing. So let's go ahead and bring those coefficients in front of the logs as exponents. So we'll rewrite the first term as log of y cubed divided by x, and we'll square both of those terms, minus log of y cubed plus our log of the square root of x to the 4th y squared. We could do a little bit of simplifying here. So we have log of, we know y cubed squared is y to the 6th over x squared minus log of y cubed is the same plus log of the square root of x to the 4th y squared is just x squared y. And we have our first term is positive and our last term is positive, so those are adding together, so we can group those together by multiplication. So we have log of y to the 6th over x squared times x squared y minus our log of y cubed. And we can do a little simplifying here. These x squareds will cancel, so we have log of y to the 7th minus log of y cubed. And the last step is grouping these together by our division rule. So if we have these two subtracted, we can combine them together by dividing them. We have log of y to the 7th divided by y cubed, and that equals log of y to the 4th, or 4 log of y. And we're done. Okay, number 5 says, let theta be a central angle in your standard position. Determine the quadrant of theta if cosine theta, sine theta is greater than 0, and sine theta, tangent theta is less than 0. And then we need to explain our answer. So let's talk about the first condition. We need cosine theta and sine theta to be greater than 0. So cosine theta times sine theta to be greater than 0. This only happens when sine theta is greater than 0 and cosine theta is greater than 0, or sine theta is less than 0 and cosine theta is less than 0. So if we have two negative numbers multiplied together, we know that's positive, or if we have two positive numbers multiplied together, we know that's positive. And cosine or sine theta is greater than 0 and cosine is greater than 0 in quadrant 1. And so next to this first condition, we're going to write quadrant 1. And sine theta is less than 0 and cosine theta is less than 0 in quadrant 3. So let's keep those in mind. The second condition says that sine theta, tangent theta must also be less than 0. So sine theta times tangent theta is less than 0. That means either sine theta is greater than 0 and tangent theta is less than 0, or sine theta is less than 0 and tangent theta is greater than 0. So we know with either one of these, if sine is greater than 0, then tangent has to be less than 0 in order for them multiplied together to be less than 0, or the other way around. Sine theta is greater than 0 and tangent theta is less than 0 in quadrant 2. So we're going to write quadrant 2 next to this. And sine theta is less than 0 and tangent theta is greater than 0 in quadrant 3. So we know this last condition is in quadrant 3. And we need to determine the quadrant of theta if both of these statements are true. So theta must be in quadrant 3. Okay, this is number 6. It says let theta equal negative 27 pi divided by 4. And we need to determine the quadrant and the reference angle of theta. So it's negative. We know we're going to go clockwise. So we start at 0 and we're going to go one full rotation. That's 8 pi over 4, or 2 pi. And we're going to go another rotation around. That's 16 pi. We're going to go one more time around. That's 24 pi over 4. and then we have 27, so we're going to go 24, 25, 26, 27. So this is our angle. Theta is negative 27 pi over 4. So our reference angle is going to be with respect to the x. So our reference angle is in red over here. So our reference angle is in quadrant 3, and you can see that equals pi over 4. Okay, this is problem number 7. It says an observer on the ground observes a plane at an angle of 30 degrees. So you can see I've put a person here and a plane in the top. The angle from which the eye level looks up at the plane is 30 degrees. The distance from the observer to the plane is 3 miles. So that is the distance from the observer to the plane, and that's 3. How high is the plane flying? I've labeled that D, so we need to solve for D. So we can write an equation using our sine of 30 as opposite over hypotenuse, so D divided by 3. And to solve for D, we cross multiply, so D equals 3 sine of 30 degrees. That equals 3 times 1/2, or 1.5 miles. So that is our height of the plane flying.
Alright, for this problem, we are asked to find the exact values of x on the interval of 0 to 4 pi. So for the following equation, we have cosine of x equals 1/2. So just using our table that we should all have memorized, we know that pi over 3 will give us 1/2, as will 5 pi over 3, and the same 0 to 2 pi bound, I guess. So we can think of it as the cosine being positive in the first quadrant, because it's on to the right to the x, and in the fourth quadrant. And our pi over 3 takes us right there. Oops, that's really sloppy, excuse my handwriting. And 5 pi over 3 takes us down here. So those are from 0 to 2 pi, but we are asked to use the bounds of 0 to 4 pi. So we need to add an additional 2 pi to each of these answers we found already. So pi over 3 plus 2 pi will give us 7 pi over 3. Oops. And then finally 5 pi over 3 plus 2 pi will give us 11 pi over 3. So, boxing our answers, we have 4 different answers. We found the values where cosine is 1/2 in the bound of 0 to 4 pi, so that'd be 2 rotations around our unit circle. For the second part of this problem, we're asked to find, within the bound of 0 to 4 pi, all the values where sine of x equals negative pi over 2. So first we can look at on a little basic graph where sine is going to be negative. And that's going to be going down on the y-axis, so we'll be in quadrant 3, being here, and we'll be in quadrant 4. Those will both give us negative values for our sine terms. So let's go back up to our problem. We see that we have negative square root of 2 over 2. We can rewrite that as negative 1 over square root of 2. If that helps you see stuff. But using our chart and our unit circle, we know that pi over 4 gives us a triangle where we have 1 over square root of 2. But we need to be in the third and fourth quadrant, so pi over 4 is now our reference angle. So let's go take a look in the third quadrant using pi over 4 as a reference angle. So in the third quadrant, we're going to get 5 pi over 4 for one of our answers. And then we need to go to the fourth quadrant as well and use pi over 4 as our reference angle. And we'll get 7 pi over 4. These are the two answers for our bound of 0 to 2 pi, but we are asked to find another rotation. We're bounded from 0 to 4 pi. So we need to add another rotation of 2 pi to these two answers. So we're going to have 5 pi over 4 plus 2 pi, which equals 13 pi over 4. And then we need to add 2 pi to 7 pi over 4 as well to get our second rotation. That'll be in the fourth quadrant. That'll end up giving us 15 pi over 4. So, using our reference angles, we found this answer and this answer for the first rotation. Then we're bounded from 0 to 4 pi, so we need to do two rotations. Thus, we added in the 2 pi's to give us these. Adding in the 2 pi's, we were able to hit on our rotations in the third and fourth quadrant our second time around.